Hi everyone, so we're going to be reviewing some fractions today. So anytime we have a fraction, it's in the form a over b. And just keep in mind that when we have a over b, that just means a divided by b, which is basically we're taking the number a and we're breaking it up into b parts. We can also rewrite this as a times 1 over b, which is the same as a bth of a. All right, so just to kind of put some numbers and have a tangible example of that, if we have 3 halves, that can be interpreted as 3 divided by 2, which means 3 broken into 2 pieces. And if I take the number 3 and I break it into 2 pieces, we know that we get 1.5 or 1.5. That's the same as taking 3 times 1/2. So I have 3 1/2s or 3 halves. I'm also, when I multiply by 1/2, I'm taking 1/2 of whatever number was right here. And I want you to notice one more thing. It's that when I had 3 divided by 2, that was the same as taking 3 and multiplying by the reciprocal of 2. So that's where you guys have probably heard the phrasing keep, change, flip before. And I want you guys to know that that doesn't only happen with fractions, that actually happens with all numbers. That's the definition of division. When I divide by 2, it's really just multiplying by 1/2. Okay, so we have an example problem here. Suppose I wanted to take 3/4 and I wanted to add that to 5/4. And so basically the question here is how many fourths do I have? If I have 3/4 and 5/4, think of the fourths kind of as if you were to, I don't know, have inches. If I have 3 inches and 5 inches, I would have 3 plus 5, 8 inches, or in this case, fourths. And then I could simplify this fraction. So I know 8 is divisible by 4. 8 divided by 4 is going to be 2. 4 divided by 4 is 1. So I get that this is equal to 2. Notice that I did not add the denominators. And I want you to understand that we don't add the denominators because the 1/4 is kind of like the thing that we're adding together. Like here I have 3 1/4 plus 5 1/4. And I'm adding that together to get 8 1/4, which is 8 times 1/4 is 8 over 4. And I want you to kind of understand the concept of what we're doing so that you don't feel inclined to add across the denominator. We do not add across the denominator. Okay, so now suppose we wanted to add these fractions. I have 2/5 plus 3/10. And now I come into the problem where I don't have a common denominator, right? I have a 5 and a 10. And so I can't add how many fifths I have together exactly because the other one is in the context of tenths. So what I can do is put these into the same kind of context. So I get them with the common denominator so I know how many fifths or tenths I'm adding, and I have the same kind of, think of it like a unit. So what this looks like is finding the common denominator. Which is going to be a common multiple of both 5 and 10. So that would be 10. And then I'm going to put 2/5 into the context of tenths. So if I have 2/5, that's really going to be 4/10. And notice all I did was I multiplied 5 by 2 to get 10 and 2 by 2 to get 4. And if I think about 4/10, that's covering the exact same quantity as 2/5. And then I can add that to my 3/10. And I can count up, okay, well, if I have 4/10 and 3/10, how many tenths do I have? And the answer would be 7/10. And again, we add across the numerator. All right, now we have another example. I have 1/8 minus 2/3, and I want to figure out how much that is. And we run into the same issue. I don't have a common denominator, so I'm going to try to change the context of this problem. I'm going to think of a common multiple that 8 and 3 share. And you can choose any common multiple. Best practice is to choose the least common multiple because then it's a smaller number that you're working with. For this one, I can go ahead and take 8 times 3 and gives me 24, which is a common multiple. And so I'm going to change 1/8 into the context of, well, if I have 1/8, how many 24ths is that? I would multiply 8 by 3 to get 24. So I can go ahead and multiply the 1 by 3 and get 3. And I want you to notice that 3 24ths is the exact same amount as 1/8. It's just in a different context. And then my 2/3, I would multiply 3 by 8 to get 24. So I multiply the 2 by 8 to get 16. And 16 24ths is exactly the same as 2/3. And then I can subtract across the numerator. So I have 3 24ths minus 16 24ths. I ask myself how many 24ths would that be, and that would be negative 13 24ths. All right, now suppose we wanted to find 1/3 of 24. Now, we kind of already talked about this right here when I said if you have a fraction and you interpret it as a times 1 over b, you're really just finding a bth of a. And so we're going to use that here. If I want to find 1/3 of 24, I'm just going to take 1/3 and I'm going to multiply it by 24. And that's going to give me 24 divided by 3, which is 24 cut up into 3 pieces. And so that gives me 8. And in fact, 8 makes sense to be 1/3 of 24, right? Because 8 times 3 gives us 24. So then 24 divided by 3 gives us 8, which is 1/3 of 24. Now suppose you wanted to find 2/3 of 24. We kind of play the same game, except instead of multiplying by 1/3, I can multiply by 2/3. And I multiply across the top, and keep in mind, I didn't write this in the last one, but when you're multiplying fractions, you can imagine this as a over 1 and multiply across the numerator and the denominator. But when I multiply across, I end up getting 48 over 3. And I can check if I can simplify this, and in fact I can. This would give me 16. But I want to point out something. So this is the procedure that you've probably learned before. But I could also, when I'm looking at 2/3 times 24, I could also say, well, that's just 2/3 of 24. So I have 2/3 of 24. And I know that 1/3 of 24, or 24 divided by 3, is 8. So I've got 2 times 8, which is 1/3 of 24, like we found in the previous problem. And that's, again, 16. Now, you wouldn't have to write this out every time, necessarily, but I want you to understand how these two problems are connected. All right, finally, we have 5/8 of 44. Go ahead and pause the video and make sure you can do this. Write your answer as a simplified fraction, and then resume the video when you want to see the solution. Okay, so when we want to find 5/8 of 44, I'm going to take 5/8 times 44. And I personally don't feel like doing 5 times 44 and then trying to divide that number by 8. So I'm going to show you how you can kind of break this up a bit and not have to do such large multiplication problems. If you want to do the large multiplication problem, that's totally fine, and it will give you the same answer at the end. I'm going to take 5 and I'm going to break 8 up into 2 times 4. And then I'm going to take this 4 and the denominator here, and I'm going to transfer it over to the denominator with the 44. And I'm going to write out all the steps for this, like the logic, so that you guys can kind of see what I'm doing. So now I have 5 over 2 times 44 divided by 4. And now I'm going to simplify the 44 divided by 4. So I have 5 halves times 11. And then I can multiply this together to get 55 over 2. And if you did the, 5 times 44 and divide it by 8 and then simplify, you would also get 55 divided by 2. All right, so multiplying fractions, we've been doing that, so hopefully this looks familiar. Just to summarize, when I'm multiplying fractions, I'm going to multiply across the top, multiply across the denominator, and then the new numerator is going to be the product of my old numerators, and my new denominator is going to be the product of my old denominators. And now I want to talk about dividing fractions. And we actually kind of went over this already in the first slide. So if you notice, when I had A over B, and I said, well, we can interpret this as A divided by B, which is also the same as A times 1 over B. What we did here is when I was dividing by a number B, right here I can interpret it as actually multiplying by its reciprocal, 1 over B. So dividing by B is the same as multiplying by 1 over B. Similarly here, I have 3 divided by 2, and that became multiplying by 1 over 2. And I wrote right here, division became multiplication by the reciprocal. And that's true for any number. Division is for sure multiplication by the reciprocal. And that works out really nicely for fractions because I can take this divided by C over D, which is tricky to deal with, and change it into a times D over C. So I'm dividing a number, so I multiply by its reciprocal. And then once I have the multiplication problem, I just multiply across the top and the bottom, and then I get my answer. So we're going to do 2 of them. If I have 5 halves divided by 1/8, I know division is just multiplying by the reciprocal, so I'm going to rewrite this problem as 5 halves times 8 over 1. And then I multiply across the top and bottom. If you want to fully multiply everything and then simplify, that's fine. If you want to notice that, hey, this 8 and 2 actually simplifies to a 4 and 1, you can do that as well. So we get 20 over 1, which is just 20. Then the second one, we have 2/3 over 4/9, which I just kind of wanted to show you this notation. If you see something like this is really just 2/3 divided by 4/9. And I'm dividing so I can multiply by the reciprocal instead. I've got 2/3 times 9/4. And I can go ahead and kind of simplify this a little bit. The 9 and 3 becomes a 1 and 3. The 2 and 4 become a 1 and 2. And then I multiply across the numerator and I get 3. And when I multiply across the denominator, I get 2. So my answer is 3 halves.